Hello everyone, this is Abby again. Today I'm going to talk about what is the best way to ensure surface mount component quality in manufacturing. There are 4 points. I will talk one by one as usual. The first one is design for manufacturability. One of the first steps to ensure SMT component quality is to design the PCB layout and the component selection with manufacturability in mind. This means taking into account factors such as the size, shape, orientation, and the placement of the components, the type and amount of solder paste, the clearance and alignment of the pads and vias, and the compatibility and the tolerance of the materials. Design for manufacturability can help reduce the risk of solder bridges, tombstones, open circuits, and the other issues that can affect the functionality and the performance of the SMT component. The second one is inspection and testing. Inspection and testing PCBs and the components before, during, and after the assembly process is a key step to ensure SMT component quality. This can help detect and correct any defects or errors that may be caused by human, machine, or environmental factors. Common methods of inspection and testing for SMT components include visual inspection, automatic optical inspection, X-ray inspection, and electrical testing. Visual inspection involves checking the PCBs and the components with the naked eye or magnifying device for any visible signs of damage, misalignment, or contamination. Automatic optical inspection uses a camera or scanner to capture images of the PCBs and the components and compare them with a reference model for any deviation or anomalies. X-ray inspection leverages X-ray to penetrate the PCBs and the components to reveal any hidden details or faults that may not be visible on the surface. Lastly, electrical testing applies voltage or current to the PCBs and the components and measures resistance, capacitance, inductance, or other parameters to verify their functionality and specifications. The third one is soldering quality control. A third crucial step to ensure SMT component quality is to control the quality of the soldering process and the solder joints. Soldering is the process of melting and soldering a metal alloy to join the components to the PCBs. The quality of the soldering process and the solder joints depends on several factors, such as the temperature, time, pressure, flux, and the cleanliness of the soldering equipment and the materials. Soldering quality control can help prevent or minimize the occurrence of solder defects or failures, such as cold solder, dry solder, insufficient solder, excessive solder, or solder balls. Okay, the last one is rework and repair. A final step to guarantee SMT component quality is to perform rework and repair on any PCBs or components that don't meet quality standards or specifications. Rework and repair involve removing, replacing, or modifying defective or damaged components or solder joints. To do this, you will need special skills, tools, and techniques to avoid damaging the PCBs or the components or compromising their integrity. Commonly used tools and the techniques for rework and repair of SMT components include soldering iron, hot air gun, the soldering blade, and solder paste. A soldering iron is a handheld device that heats up a metal tip to melt and apply solder to the components or solder joints. A hot air gun blows hot air to heat up and remove or revolve large or complex components or solder joints. The soldering blade is a woven copper wire that absorbs and removes excess or unwanted solder from the components or solder joints. Solder paste is a mixture of solder and flux that is applied to the components or solder joints before soldering. That's all for today. If you have any questions, please feel free to contact us. Thank you and bye bye. See you next time.